Hi everyone and welcome back to your channel FE Civil Exam with Farhad. Mechanics of Materials, Support and Reactions Calculation in 1 degree indeterminate beam with distributed load of W. In this example, in the previous video, we already solved the problem for calculation of the reaction at supports like R sub A and R sub B. This time we want to calculate the theta at B. So to follow, we have solved this problem with like 4 different approaches. Like the solution 1 is determination of elastic curve from moment coming. Solution 2 is considering the moment as at A as a redundant and then considering the reaction at B as a redundant. Then the final one was the Castigliano's method. So already calculated the support at RA and RB. This time we are going to calculate the angle created at uh, at the end B. So theta B is the topic for this talk today. So as we know, the Castigliano's method is based off energy, is an energy method, and that's going to calculate the reactions and also the angle based off the partial derivation of the strain energy method to calculate the uh, re theta or reactions. So this time we do know that the strain energy in beams are calculated based integration from 0 to L m squared over 2 EI dx, and then if you want to calculate the theta, we need to develop or create a virtual moment at that location, and then that angle or theta sub b, that's a partial u over partial mb. So this is our mb, which is the virtual moment. We create that to calculate the angle created at theta b, and by taking a partial u over partial mb, we can calculate that angle. So theta b is just simply, if you expand the equation, that's partial u over partial mb integration from 0 to L m over ei partial m over partial mb dx. So it just says we need to we need to cut the beam through at some length like x, and then develop the moment equation considering the m sub b. Again, we expand the equation of u partial u over partial mb, and that's the equation we have. And then by developing the moment at x, we can get the moment for our beam considering the virtual moment mb. So m sub x is equal to rbx minus the resultant force, and then wx squared over 2, that's the effect of resultant force apply at the x over to create a moment, and that's this one, and then negative mb. So as soon as we have, and also we already calculated RB is equal to like 3 over 8 WL. As soon as we look at the moment equation, partial M over partial MB, that's simply -1, this part. And RB is already calculated in previous video, that's 3 over 8 W over L. I will provide you with the link to that video to see how we can calculate RB and RA. So definitely if this is 3 over 8, the total is WL, so RA should be 5 over 8 WL. Then this is our expanded theta B equation. We can simply take the constant 1 over EI out of integration. Then M is here, this is our M, which is we calculated in the previous part, and this is partial m over partial mb. So how can we recall that from our calculation? So this is our rb in the equation of moment, and the rest is, we also know that mb, that was a virtual one in the real or original beam, we didn't have any moment at B, so that goes to 0. We just need this derivation to locate at here. So the other one, it just says theta at B is equal to this equation, and if you do the math, it just gives you a negative WL cubed over 48 EI. And so far we have calculated the reactions and RA and RB, and also the angle created at B with the approach of with the solution of Castigliano's method, both for theta and reactions. Thank you. We'll solve more video related to beams relations. Thank you.